This is what most people think of when they think of a failed septic system, where you have septic tank effluent coming to the surface like we have here. Although this is an issue that needs to be addressed, this is not the most common septic system failure. Now, as nice as it is sitting here, let's get out of here. That's better. So let's talk real quick about what an existing system compliance inspection consists of. There's two things that are mainly looked at for a compliance inspection. One is the integrity of the tank. On the sheet, it's called tank integrity. And what the inspector is looking for is whether or not the tank is watertight. And there's a number of different methods that can be used to assess whether or not the tank is watertight. But one could imagine if there's a crack in the tank and the effluent that's in the septic tank is able to leach out, that is a system that is failing to protect groundwater. So that's one tank integrity issue. The other is just as common. Back in the 60s, or before septic regulations came in line, a lot of the tanks that were put in didn't have a bottom. And these are called cesspools or dry wells. And without a bottom, again, this effluent in the septic tank can just freely leach out and not get treated before it hits any kind of groundwater. So this, a cracked tank or a cesspool are both considered a tank integrity issue in a septic system that would require a replacement. So that's one item that's looked at. The second item is what we call soil separation. What does that mean? That is simply a vertical distance between the system bottom and any type of restriction that is found during the compliance inspection. So let's imagine this system right here. Let's imagine that this distance is 24 inches. So the drain field trench was installed 24 inches into the soil. Now let's imagine that there's water at some point below the surface, which there usually is. So this is water table. Now, the first thing the inspector is going to do is he's going to determine what this depth is, either by tile probing or old permit records. He's going to determine the depth of that system, and then he or she is going to come out, go some distance away from the drain field, and take a soil boring to determine where the depth of that water table is. Now, this distance here between the system bottom and the water table has to be greater than or equal to 36 inches. If that is the case, this drain field trench is deemed compliant. Because in order for the sewage or the effluent that's leaving the septic tank to be treated in the trench, we need 36 inches of unsaturated soil for all the pathogens to be treated before it hits the groundwater. Now, if that compliance inspector determined that this depth, let's say, was 48 inches, now this distance is what? It's 24 inches. And that is a non-compliant system, because just like the leaky tank, it's failing to protect groundwater. A lot of times when people hear the word failing, they imagine what was in the video earlier with me standing in a puddle of septic tank effluent. That's usually not the case. That's an imminent threat to public health. Failing is failing to protect groundwater. Now, water table is one of the restrictions that we can find. Another one that's common in Washington County, especially in the south part of the county. There's a lot of bedrock very close to the surface, and that is also deemed a restriction. So we need to have that 36 inches of vertical separation between the system bottom and bedrock. Okay, here we have a real soil profile in Washington County And we have this tape here to show you the depth of the soil and the restriction. And here we have a very obvious restriction of sandstone, which is bedrock, and we need to stay 36 inches away from that. So you can see with this tape here, if we were to put a system 12 inches into the ground, we would only have 6 inches of vertical separation between the system bottom and the restriction, and we wouldn't get adequate treatment before the sewage enters the bedrock. So what we need to do in this situation is we need to artificially provide the rest of the separation by putting sand on the ground. In this case, we're about 18 inches below grade to a restriction, so we put 18 inches of sand above the ground and then put a pressure bed on top of that, and that's where a mound comes in, which you can see behind us. That's what we're building at this site because of this restriction.